Let's take another crack at these skew and kurtosis and ideas a little more closely. These are the ones we were looking at right at the end of class on Tuesday. Let's go through these together. This is that first example about sales data. And I don't have a single picture involved here. But what can I say about the direction in which this data appears to be skewed? Does it appear to be skewed? Okay. Right, higher numbers are on the right side, lower numbers are on the left side. And I said, so let's think about, I didn't sort these, right? I could sort them, even if I just did that right here. Move that. Sort, let's sort by units sold. Regardless of which way we do it, now they're at least in order, right? So does this look like it's going to have a center closer to the left side with long things on the right, or is center closer to the right side with long things on the left? Which way do you think? Just based on these numbers. So you think the center is on the left or the skew is on the left? So that means the center should be further to the right. Yes? Okay, so the center being further to the left and the long tail being more on the right. I got to figure out where's the bulge and where's the middle. Felix. Which means that the center would be more to the left and the long direction would be to the right if we get a positive skew. So let's actually calculate it. Skew of these items. If it's positive, then my longer tail will be to the right side. And that should mean that if I made a dot plot or some sort of histogram or frequency chart, I'd see the center of this data further to the left rather than symmetric in the middle. And yes, that is a positive skew. So the average of these numbers should be further left than the middle of the range. What's the actual middle of the range here? These numbers go from 10 to 120. Where's the middle of that? Good catch. What's halfway between 120 and 10? Say again?
115. So 120,
120 and 10.
Oh, I think.
Did I say 110? If I did, that's my mistake, but I meant 10.
I couldn't.
65. The middle of this range physically, halfway between 10 and 120 is in 65. And there are more low numbers below that midline than above that midline. So it makes a little more sense that we have more numbers on the low side and our long tail would go to the right. I don't have an image. I don't have a histogram. I don't have any sort of plot here in my head. But look at these numbers again. Again, we'll sort them just to make sure. Sort, oh, wrong way. Sort, custom sort, not by student, but by exam score. Sorting by exam score shows me all of these 5 units apart. 75, 80, 85, 90, 95. They're exactly the same distance apart from one another. And there's one in each spot, right? This is the same as if I gave you the numbers 1, 2, 3, 4, 5. They're the same distance apart all the way across. And there's only one of each. If I tried to make a histogram of this, it'd be flat. Compare that idea to our distribution and the idea of tails. If I've got tails, I would expect some sort of diminishment as I went out from the middle. But here, there's no such thing, right? So, what is the actual computed kurtosis here? KURT. Now, with the discussion we were having previously, if there are long, thin, skinny tails, I would expect a big kurtosis, a positive excess kurtosis. On the other hand, this distribution seems pretty flat. There isn't much tail going on here. I should expect a low kurtosis. What do I actually get? What's your number? Whoop, I forgot a parenthesis. Let's go back and fix that. There. I'm rounded, but it's still negative, right? And that tells me it's flattened out. That those tails don't stretch out. The distribution kind of squishes down and gets fat all the way across. Because everything is here at the same frequency, at the same relative occurrence, this is called a uniform distribution. Every number appears here exactly once. They're all the same height. If we drew the actual histogram, it would look like a horizontal line, wouldn't it? That's called a uniform distribution. But let's actually make a histogram. Remember, there were a couple different ways to do this. I want you to make a histogram. I've specified bins. How do I make a histogram with specified bins? I got to go to data. Data. Now. Way over here. Boop. And histogram should be on this list somewhere. There it is. Click OK. Tell me where the data is. So I want the upper limits of my bins. I did highlight the label on revenue when I did that. So I'm going to click the labels button. And then I want a chart. And I'm going to have it put this on a new sheet. You could have it put it somewhere in here if you tell it that the output range should be a given cell. But I just want it on a new sheet so it's not interfering with any of this. If we wanted, like if we had qualitative data for my bins, I could use that sorting with the highest bin occurring first. I could put a cumulative behavior on here, but this data is small enough, I don't think I need it. Here, I made an error. What's my problem? What did I screw up? First bin's missing. Since I clicked labels, I must have missed labeling that first, the bins setup, right? I must have mislabeled that and not used the right bins. You see how the label at the top of the bins is 500? It assumed that the first thing in that list was the label. I forgot to highlight the word bins. So let's delete this sheet and repeat the process. Boop. So with my bins, data analysis, histogram, the input range is correctly highlighted. The bin range, yep, there's my mistake right there. The word high isn't highlighted. Now all the bins and the label that goes with the bins. The other thing I could have done was to get rid of the label and uncheck the labels box. There. Okay. Based on this histogram, what would I suggest about the skew here? We could actually go back and compute the skew, but we didn't yet. But based on this picture, what would you expect to get out of the skew? Because the larger frequency is on the left side. I agree with that. The problem is that means that the tail is going to the right side, and it's the direction of the tail that tells me negative or positive. And the right side is the positive side. So while I agree with you, the lumps are over here, that unfortunately means the skew is that way. It's positive. It's always the direction. It took me a long time to get used to this too. So let's actually go compute the skew. Please notice that when this new sheet was inserted, it was inserted to the left of the data we were working with. So down here, this thing that says sheet 2 is the third sheet. The revenue is the fourth sheet. So put it to the left of. That's automatic. We can't fix that. We can move the sheet if you want, put it on the right just by dragging it. If I go over here and I ask for the skew of this data, I'm hoping I get a positive number. Okay. I made up the bins. There's no bins here. And this time it's asking for a chart as opposed to a histogram. Now, when I did the histogram, it gave me the chart. There's the chart. But I can do the charts on my own. And there are two different ways to do this. The frequency formula, but you have to either specify the bins in braces. Again, you're only specifying the upper limits. Or you have to have the bins written down somewhere, the upper limits of the bins, and use those. What are good bins here? What should we group by? Like that? And so if I go down here and I say equals frequency, I could actually just say I'm going to use these data cells And then for the bins, I can use these data cells, right? And there's my list. 2 in the first bin, 2 in the second bin, 1 in the third bin, right? But if I hadn't listed those as cells somewhere, same set of data, but then I could actually write in the bins themselves, the upper limits of the bins. Same exact result. I know it says there you must hit Control-Shift-Enter for an array function. I know that's true on a PC. I don't believe it's always true on a Mac. Some array functions work when you just hit enter. Some don't, so be aware. Once I have the frequency table, I can do anything I want to it. I can format it, right? I could actually copy these bins over here. Oops, helps if I put them in the right place. And then this is my frequency table, right? Okay, let's make it look pretty. I'll put borders on it. I'll center it within. I'll double click this so it looks the right width over here. I'll change this to say count, or you could actually write the word frequency. And then that needs to be set apart. How about a clearer border and boldface? There.
Isn't it pretty?
It's easier to read. Yes. In a lot of table setups, there are alternate colors of lines so that you can stay on the correct line as you go across. Questions? The box edges, the formatting, the font, and all that in the upper left on the home ribbon. Talk to me. You've seen this before, right? Okay, good. Let's extend this just a little. So I've got the frequency we just created for a new set of data. This is in the L11 file, which I have right here. That's that frequency formula. You'll notice at the very top, the very first set of frequency, that command is actually in regular text up there. But if I go to a lower line, it's grayed out. That's what an array formula shows me. It only is editable from the top line of the array. So if I want to edit this frequency formula, I need to be in that top line box. What's that result? Why is there a 0 there? I just hit frequency. Where's the 0 coming from?
This is just guess, but is that just there if there's any data outside of the range or?
There's no label on this bin, but it's the data that would be above my last bin. Technically, that should be labeled more. If I automatically generate the histogram with the bins, it'll have that category more. That's what that is. You're exactly right. But it doesn't label it automatically when we use the frequency command. Okay. What's that? I'm extending my ideas of frequency. REL here is short for relative frequency. So I'm taking the percentage of the total number of data values that occur in each bin. So the formula takes whatever's in the frequency column, divides it by how many things are in the original data pile. I've given it as a decimal. You want to give it as a percentage? That's fine. You format the column however you want. I just counted how many things. What do you notice about those red cell markers? And what do the dollar signs do? They're absolute markers. You'll notice that H4, the blue cell, is not dollar signed because I actually only typed this formula once. I typed it here. And then I just copied it down the rest of the cells. The non-absolute one changed for each row when I pasted it. The dollar signs force that to stay the same. And that means that I don't lose the table as I move around. If you're going to do this for a fairly large table, you're going to do it over and over and over in different places, and you need to keep referring to the same table, you can do this. You can also create a name for a table and then refer to the table name. I hope this is not a dumb question. I hope the answer is pretty obvious. What's the sum in that column? If I summed up that column, what should I get? I should get everything, right? I should get 100%. 100% is 1. Total in that column should always be 1. So no matter how many data points I actually have, a relative frequency as a percentage must count everything. What's that? This is again just a count. I've not done percentages or anything here. This is a count, frequency. What's the word in front mean? Cumulative. So what this is doing is it's taking all the data, not just in that one frequency box, but everything above it. Everything from here down. From the lowest value up to the top of this bin. It's accumulating. By the way, the very first one of those just says add up whatever's in that box, starting at H3. Notice the dollar signs, and going to H3. Notice there's no dollar signs. So as I copy that formula down, the starting point of the sum stays at the top box, but the ending point gets bigger. And so down here, I've now added all the way down, but I'm still starting at the top box. And again, I should eventually account for everything, right? There are 20 values over there, 5 rows of 4. So eventually, I'll have counted them all. Do them together. That's what that last column is. Cumulative relative frequency. That adds up the percentages the same way. I can do that in two different ways. I can do that same sum command on this column, the column of relative frequencies, or I could do this divided by the count. The same way I created the relative frequencies in the first place. I would like you to do a histogram for this data with this set of bins, but I want you to check another option when we do the histogram here. There should be an option that says cumulative. Please check it and tell me what you get. Yes, sir. So you need to pin the starting point of your sum to the top row. That's what the dollar signs do. And then just go down to whatever your current row is. So you add up from the top to wherever you want to stop in the data. Question? About, okay, so let's walk through the histogram. So I'm going to go back to data and to data analysis all the way over here on the right. Histogram. Where's the data itself? The data itself is here. Right? Enter. The bin range is here. I didn't use the labels in either case. I have to use the upper ends of the labels. Well, that depends. In some cases, we'll be given them, and in some cases, we won't. So we'll actually have, as soon as we finish this one, we'll talk about how to come up with the bins. I hit enter on this. I uncheck labels because I didn't highlight them. And now I want a new worksheet, and down here, there's another option that says cumulative percentage. I want that as well. So what happens when I do this? Do you have a question as well?
I can't find it, even in my search bar.
Can't find which.
Data process.
Okay. There is a requirement that you have the data analysis tool enabled. Let me finish this, okay, and then I'll jump back and get rid of what we've done, and I'll come back to it. Up here under Tools, if you do not see Data Analysis under Tools, then you need to go to the second from the bottom that says Excel Add-ins. And there is where you turn on the analysis tool pack. If it isn't there, we need to go to IT and figure out how to get it onto your machine. If that's not turned on, please turn it on. There are other tool packs we can use, and they do different things. If you hit the browse button, you can go through a library of other tool packs. I've added the solver tool pack as well, because there are some places where I want to set up equations in Excel and solve for certain things in them, like polynomial behaviors and other things like that. Later. Other course. Cancel. Did that help you make the histogram? Okay, so the result of this histogram is something new has been added. My chart now has lines on axes on 3 sides instead of 2. I have the horizontal axis with the bins. And on the left, I have count, my frequency. That's exactly what I expected. My frequency. And then I've got this orange line, curve thing. And those are the cumulative percentages connected. See how they level off as we get to 100, right? We're increasing, we're increasing, we're increasing. Okay. The steepness versus flat of this curve, which by the way is called an ogive, O-G-I-V-E, and I will forget that term regularly. We'll just call it the cumulative curve. Where it's steep and where it's flat helps me understand more about the skew and the variability of this data. If it's really steep at the beginning, then there's a lot of frequency at the beginning, isn't there? And if it's really flat at the beginning and it's steeper over towards the right side, then there would be more data on the right side. This helps me. Where is it flat? Where is it steep? Which direction do I skew? This is flatter on the right and steeper on the left. I'm probably skewed to the right a little. Not a lot, because you can see there is a clear peak here further on the right. That might balance it out a bit. Questions? So I was asked, how do I choose bins? Well, there are really a couple of different ways to choose the bins. But it usually depends on how big your data set is. The larger your data set, usually, the more bins you want to use to try and get a handle on how these large number of things are broken out. There is a formula developed that is strictly based on a bunch of examination of other data sets, a guy by the name of Sturges. Assuming The little n here represents the size of my data set. I would probably be best off figuring out what power of 2 is closest to n. Powers of 2, 2, 4, 8, 16, 32, 64, I double every time, right? If I want to know the power, okay, I got to go back to my algebra class for a minute. What's the name for getting that power out of an exponential? If I was undoing something with an exponential in it, there would be some other thing I would do on my calculator. There's even 2 different buttons on my calculator. Do you help me do this? Anybody remember this crap? Algebra was a long time ago, man. To undo an exponential, to get that power out, I'm using a logarithm. So Sturges said, what I really want to do is I want to figure out what power of 2 I should be using. That is a logarithm in powers of 2. Oh, and we should round that up. So let's take that and add 1 to it. There's a slight problem with this. Grab your calculators. You don't actually have your physical calculator with you, grab your phone calculator. It'll still work the same way. My calculator doesn't have a button on it that says log with a 2 under it. But I do see a button that just says log, right? You see that button on your calculator? It might be above something that says like 10 to the x or e to the x somewhere in there. You should have a button that says log without the 2. Well, that's the science logarithm. That's logarithms with a power where I'm looking, instead of powers of 2, I'm looking at powers of 10. So I want to be able to switch from powers of 2 to powers of 10. The easiest way to do that is to multiply by 3.3. There's a formula why that's the number to multiply by. The change of base formulas for logarithms, which of course you all memorized back in your, no, I don't remember this one. 3.3. How many people, how many data values were in our data set? The one we're just looking at? The customer spending data? 20. So that's my n. So tell me, according to that, how many bins should I have? I should either have 5 bins or 6 bins, right? I don't want to use 5.3 bins. I don't have 5.3 bins. I need a whole number of bins. So it should be either 5 or 6. Let's go back and look at the data again. Here's the data itself. It goes from 15 to 75, right? How far is it from 15 to 75? So if I divided that into 5 bins, each bin would be 12 units wide, right? 15 to 26, 27. So I could figure out how far each bin should go. On the other hand, if I use 6 bins, 60 divided by 6 is 10. 15 to 24, 25 to 34. That's where I got these numbers from. I decided 6 bins is going to give me a good dividing range. So once I have the number of bins, take the maximum minus the minimum, that's your range, divide by the number of bins. And that tells me how wide each bin should be. I can spell. And then I can decide if that's a useful number, right? Because then we get to make executive decisions. Oh, this says that my bin should be 11. 11 is going to give me some really weird limits. We just came up with 12, right? That was a weird limit, right? 15 to 27 to 39. Those are weird limits, aren't they? On the other hand, if I use the other version and I go 6 bins, I get limits that are bins that are width 10. And grouping by tens makes more sense to me. There's something aesthetically pleasing about working by tens, right? Most of the time. But I might be able to say, oh, this data, I'm looking at sales of, excuse me, sales of corporate merchandise, and I've got numbers that are in the thousands of dollars. Maybe the right bin width is numbers of thousands. Maybe it's 500s. Maybe it's, I do the thing and it's $732. The bin width of 732 going to make anything look nice? So maybe we make it 750. Maybe we make it 700. So this is just a guideline. It isn't a requirement. This is how many bins you need. But when you have very few bins, you don't get a lot of differentiation in your histogram, do you? And if you have a lot of bins, then all your columns will be really short. And you won't get enough differentiation about where the peaks are. So this kind of balances that game. You could redo this set of data with a different bin width and see what happens. That's absolutely something you can do. You can go through and change the bins however you want. As a matter of fact, you could do it automatically by deciding on the bin width. Let me go back to the spending. What if I wanted the bins to be of width 12? I don't know why I would choose to have the bins of width 12. But then this number would be 12 more than that one. And I could just copy that all the way down. And these numbers should be one less than the bin next. And if I copy that all the way down, there are my bins, aren't there? This bottom one would be the more bin. I don't need that one. Oh, I do need the number though. And notice what happened. My frequency changed. My cumulative frequency and relative frequencies all changed. And now I have a different investigation of what's going on. You can adjust those on the fly. So in a very real sense, this is where you, as an analyst, need to justify your choices. Why did you choose a bin width of 10, 12, whatever you choose? That's your call. Questions? Please notice that the histogram is static. I made it. Just went back and changed the data. The histogram didn't change because it's got its bins already nailed down. This chart was created from the old set of bins. It didn't change. I would have to rerun the histogram with the new bins to see a new picture. Questions? So here's the same setup. New set of data. Number of tasks completed per employee. You'll notice I did something very different here. What did I do that is substantially different? Yes, sir.
The table is pretty. The way you order them.
Well, I just put them in sorted order, right? I just sorted the order compared to what was provided in the data sheet. In the actual data sheet, they're in 2 columns, right? I just copied and pasted down to make it one whole column. And the whole reason I sorted them was so that I could look at the bins and try and figure that out. But even with that, there aren't any bins here. I just counted each individual value. Technically, my bins are of width 1. How many 3s? How many 5s? How many 7s? How many 8s? How many 10s? How many 12s? How many 15s? I didn't group them at all. I could. How many data values are there here? That wasn't a rhetorical question. How many data values are there here? That's how many distinct data values there are. But the actual data is over here. How many values are there? What's our N? 10. So if I use that rule to figure out how many bins I should have 4 bins. 1 plus 3.3 times the log of 10. Log of 10 is 1. So that's 4.3. I should either have 4 bins or 5 bins. The numbers only go from 3 to 15. If I have 4 bins, each one should be of width 3. So 3, 4, 5 is a bin. 6, 7, 8 is a bin. 9, 10, 11 is a bin. 12, 13, 14. Oh, I'm going to end up with 1 bin higher, aren't I? I'm going to end up with a 5th bin. If I use 5 bins, 15 to 3. So we could regroup and create bins of width 3 or bins of width 2. You absolutely can do that. Your choice. But does this version of the data give me a better picture than this version of the data? It's a small data set. I'm not sure one is particularly more useful than the other, but that's your call. Questions? If differentiation by individual values is important to the setting we are in, I'm looking at the number of tasks completed per employee, then maybe the difference between 3 and 5 is really important, as is the difference between 7 and 8. Maybe having those in the same bin is a problem. On the other hand, maybe it isn't. And then I could do more grouping. I could also then analyze the tasks themselves. Is the employee who's only getting 3 tasks done per whatever new? Are they being given more complex tasks? Are these tasks explained as well? Or is the person who's getting these 15 done been there for 25 years and knows these tasks like the back of their hand. And what is taking the new person 30 minutes is taking this experienced person 3. I have been in higher ed for over 30 years. So when someone asks me, by the way, for almost all of that time, I have taught an algebra class and or a calculus class. When somebody asks me a calculus question, I get it done really quickly because I've been doing it for over 30 years. If I gave you a calculus question, you might very well need 2 hours. You might need 3 minutes, but you might need 2 hours. How many of you have taken a calculus class? Just a few of you. So some of you will get this done. Just a minute or two, if you remember. Maybe calculus got purged from your brain after the AP exam and you don't want to remember it anymore. But if you use it, you keep it. And if you don't use it, you'll lose it. Maybe that's the difference here. But now I have information and I can start making decisions from it. Remember, that's the whole purpose of this. Data-driven decision-making. It isn't about, oh, I got these numbers, aren't they pretty? It's what does the number tell me? It is possible that there's absolutely no use to trying to bin or sort the data in any meaningful fashion here. This is sales by region. Why would you sort these in anything other than, I don't know, alphabetical order? Sort them by low to high or high to low? But does it matter? They're just labels, right? North, south, east, west, central. Having relative frequency, oh, we're doing really good in the east, not so good in the west. Thanks. So either I need to advertise more in the west and less in the east to try and move some more product, or I need to understand why the product is selling differently in these different regions. Questions? All it asked for was relative frequency. So I didn't actually make a frequency diagram here. I simply did in each line take the number and divide by how many the total is. Notice again, the red cells are absolute. So when I copy and paste this formula, those don't change. Questions? The hell? Don't boot that on me. Thank you. So, again, I'm going to give you a data set. And I'm going to tell you to go to town. And there are a couple of things we need to make clear when we're working on this. When looking at any data set, I really need to start with, what do I need to learn from this data set? What are the questions I am trying to answer? What is the objective of this study? Again, it's going to depend substantially on what data set you're given, what instructions you're given, what your boss tells you wants to know. What are you going to get? You've got the data file. What's the first thing you need to do with your data file? Clean it. Clean the data. In this case, as in every other, look for duplicates, remove them. There's that instant option in Excel. Check for missing information. Are there any blank spaces in any of the rows and columns? Is there something that is conflicting? I got this report here, the reported number on this day at this time, and then over here I have the same date and time with another report. Wait a minute, I got to look at what's going on here. Maybe it's not a duplicate. Maybe there are actually conflicting pieces of information in the files that were put together. Organize your data however you need to. Sort it, rearrange it, whatever it is, but you must clean the data. In December of 24, a study done by one of the students on the volleyball team and I was published, and it was a data analysis of mental health and athletics. I think the title officially is Bump or Spike Inside the Mind of a College Volleyball Team. But the very first thing we did when we collected player performance data and survey data on their stressors and their mental health, the very first thing we did is take the person who stopped answering the questions out of the survey data. Whole bunch of blanks, not going to help me, throw it out. Clean the data. Somebody who was injured, stopped performing on the team, okay. Their data is only valid to this point. If I'm doing a whole analysis, I probably need to split it there. Maybe one of your stores closes in the middle of the month. Well, that sales data is going to be awful skewed, isn't it? So maybe you have to do the first half of the month and the second half of the month separately. But that's something we can then look at in our central tendencies. And here's again where you have to make a decision. Your questions should reflect what kind of data you've got. You have data that has a lot of extreme values, whether they're low extremes or high extremes. If you do you want a measure of center that is sensitive to those extremes? Will an average be useful there? Or would a median be more useful there? Maybe you want to look at frequencies and you really do need a mode. But whichever one you choose, you need to justify your choice. Why did you choose to use the mean? Why did you choose to use the median? Now, you may not have to justify that to me in this course because I will actually give you more explicit instructions. But you might want to think about, oh, why did Dr. Sassmore say, why did Dr. Burns in this assignment write this up this way and say we should use median or we should use mean? Once I have a center chosen, I'll ask the same question about spread. And that means looking at range, variance, or standard deviation. Now, those are variance and standard deviation are associated with mean. If I'm not using mean, that's not going to be helpful in the same way. There are variability measures for the median. We'll talk about them in stats next semester. It might also be useful here to look at skew and or kurtosis. Because then I have a better justification for the mental picture I've created of this data so far. But I don't just need mental pictures. Let's actually construct pictures. How about a frequency distribution or a histogram? Whether you include that cumulative percentage output or not, I can at least create an appropriate set of visuals or tables or some sort of combinations that will allow me to figure out what's going on in these piles. I've done all the analysis. What's the last thing I should do? Well, that's down here, right? I'm doing the visualization. There's one more step here. What's the last step involved? I came up with questions to answer. Where do I answer the questions? That's the last thing. What's my conclusion out of this data? I did all this. What's it tell me? What information do I have? What have I learned? And can I answer these questions? And perhaps I can't because I don't have enough data. Or I have enough to say, I think this, but we should gather more data. Further, studies are warranted. Polite way of saying, give me more money, I'll do another pile of research. Once you've done the analysis, you write up your report. I don't care if that's just answering the quiz questions that are in the quiz for this chapter, the module, or if that includes, a detailed report to an external person. Oh yeah, my boss now needs this 1 page so he can go present it to the board of trustees or to the chairperson of the board. Somebody somewhere is going to read the work you did. Make it readable to them. There's a question that usually isn't asked here, but I think should be in the back of your mind whenever you do these sorts of things. I've drawn a conclusion about this data. Is it practical for me to try and do something about it? How many of you have eaten a meal down in low dining hall past week or so? Do you know what's not in low dining hall anymore? Trays. Do you know why there are no trays in low dining hall? Anybody know? We used to have those big black cafeteria trays, and everybody would get a tray and put their plates on and wander through all the lines and get what they wanted. Do you know why they got rid of the trays? Waste numbers were through the roof. I could fit 3 plates on a tray. Damn it, I was going to fit 3 plates on a tray. Food waste went down 80%. All I did was get rid of trays. Is it a practical thing for me to do? In that case, the answer was absolutely. What else is not in the cafeteria anymore? Disposable takeout containers. If you want to take a meal out of the cafeteria, you buy one of those plastic green containers, right? They used to have the foam ones that you threw away. Nobody recycles styrofoam, people. They were going directly into the landfills. We got rid of them. We stopped buying it. Now, it was a substantial investment to buy all those green plastic totes and to wash them and to make sure that you could just trade them in and you didn't have to worry about it. Bring it back, we'll give you another one. Every time. Means we have to have enough of them. We have to clean them. We have to store them. The foam ones? Ah, here you go, and it's garbage right after that. So that was an expense incurred because of the analysis we did. So include in your answering of your questions, is this a practically doable idea? We'll see more about that in the next module. So I got 8 minutes left. So on Tuesday, I want you to work on the project file for this module. So we'll do that in class and talk about all these sorts of things. I will see you all then. Hope you have a good one. If you came in late, please come sign in. At some point will turn that into a seating chart. I promise.